All right, so I've come up with a bunch of practice problems that are pretty similar to our homework problems, but not them at all, actually. Um, so we're going to go through how to kind of work through these and just kind of better understand the processes for that. So for this first one here, we're going to evaluate for the limit of this function as x approaches 7 1/4. And remember that a limit means that, like, if I have this, nope, that's not a function. If I have, like, this function, and I was looking for maybe the limit as x approaches this point, right? I'm looking for whatever y value they're approaching from both sides. I want to know what the function is getting closest to at that point. Remember, there doesn't always have to be a point at the x value that we're approaching. So maybe I have a function like this, except there's a hole in it, so it's like this. So maybe there's no value at this point here, but we want to find the limit right here. Well, that's okay because we're still approaching this, aren't we? So we're just finding what point we're approaching. That would be whatever y value this hole takes this place of, even though that value doesn't actually exist within the function anywhere. It would be undefined. So the first thing we typically do when we want to find the limit of something is we try what we call direct substitution, which is where we directly substitute this in for x. We just kind of plug it in. So we're going to go ahead and try that for this one. So it's going to become 4 times 7.25 minus 1 over 2 times 7.25 plus 3. And if I do, let's see, 4 times 7 is 28, so it's going to be 29 minus 1 over, it's going to be 14 and a half plus 3, or 28 over 17 and a half. Obviously, we don't want a decimal in our fraction. That's a little ugly. So we'll just double this to get that out of there. So that'll be 56 over 35 is our limit. We're going to go ahead and try the same thing for this one here and see what happens when we directly substitute it. So we've got x is approaching -4. So when x is approaching -4, we want to see what y value the function approaches, right? So we're going to start by just plugging that in and seeing what happens. So we'll get -4 squared, which will be a 16, plus 11 times -4, or a -44, plus 35, all over -4 plus 4. And when we put that together, that ends up being -35 plus 35, or just 0 over 0. This right here is something that we call an indeterminate form. And when we get an indeterminate form, it doesn't mean that the limit doesn't exist. It means that we actually don't know if it exists or not, and we have to try something other than the method we just did to figure out what the limit is. So direct substitution didn't work, but let's see if we can factor anything out of this. So let's take a look here. Let's try and alter our limit a little bit. So it's going to be, so it's an x plus 4 on the bottom. Let's take a look at x squared plus 11x plus 35. And so I hope that we all know how to factor at this point, because if not, it's going to be pretty tricky to do a lot of our assignments. But so this should factor out, I believe, to an x plus 4, x plus 7. And we can double check that by foiling that out. That's going to be an x squared plus 4x plus 7x plus 35. Oh, so yeah, this is what that is. So put x plus 4, x plus 7. And right off the bat, we kind of see how that helps us, because now we can cancel out these x plus 4s, and it just becomes the limit of x plus 7 as x approaches -4. And now we can try that direct substitution again because there's no reason it wouldn't exist at this point. So that gets us a -4 plus 7, or just a limit of 3. And if you're ever unsure about these, you can always double check them graphically with a calculator or Desmos, what have you. But we're going to go ahead and try the next one, which it looks like we're going to get that indeterminate form again, because we're going to get a 0 on the bottom and a 0 on the top. But it looks like this one's just a little bit more confusing. But it kind of feels like we can factor out an x plus 5, right? So let's try and figure out how we can factor out an x plus 5 from this here. So if I have an x plus 5, I need to figure out what I'm going to multiply to that's going to get me this. Well, I know it's going to be an x squared, because I know we're going to get that. And if I multiply those bits, that's going to get me an x cubed plus 5x squared, which is a little tricky, right? And I know for this bit, I'm going to need a plus 25 in there, because 5 times 25 is going to get us to 125. So that's going to get us a plus 25x and plus 125. So now I've got this going on here. Oops. Oh, I see. So now we need to figure out what's going to go in here that'll get rid of these. And I won't lie, this isn't my strong suit, and I didn't solve this problem ahead of time. So just give me a moment to kind of process this. Let's see. We could do, there's a minus 5x in there, and a I think that would do it, because that would then multiply with our x to get a negative 5x squared, and multiply with our 5 to get a minus 25x, which will get rid of those bits. So now we've just got this right here. So we're going to go ahead and put that in. So we factored this out, and I'm going to rewrite this bit here. And now it's going to become, on the top, we've got an x plus 5 times x squared minus 5x plus 25, all over x plus 5. And again, we see that we can just cancel those out. And I'm going to erase this bit over here now because it's in the way. And what that's going to get us is, now we're looking for the limit as x approaches -5 of just x squared minus 5x plus 25. So let's go ahead and directly sub that in. And that's going to get us, let's see, it's a 25 plus a 25 plus a 25, and our answer is 75 is our limit. Awesome. So now we're going to take a look at number 4. And so they give us here that f of x is equal to x squared over x plus 1. And so we're going to just figure out what f of 0.2 is and what f of negative 0.1 is to start. So all that is, there's no limits here, obviously. We're just evaluating the function. So I'm just going to plug that in. So f of 0.2 is going to be 2/10 squared over 2/10 plus 1, which is just 1.2. 2/10 squared should be 0.04. Hold on. 2/10, 1/5. Oh my goodness. Brain fart. Yeah, no, it's 0.04. Okay. So it's 0.04 over 1.2, which you can evaluate that however you like. That's going to be this teeny tiny decimal here. So I'm going to just put that right there. And now we're going to do the same thing, except we're evaluating for negative 1/10. And that's going to get us, so it's going to be negative 1/10 squared over 1 plus negative 1/10, which is going to be 0.9. Should be 0.01 over 0.9, which is actually a really long repeating decimal. So we're gonna actually just round that off to that decimal place, but those ones just repeat. And so now we want to use this to approximate this limit. So the limit of this function as x approaches 0, well, these two numbers are both really small and really close to 0, so they can help us approximate because they're on either side of x equals 0, right? Because if I was looking at a number line, I've got 0, I've got my 0.2, and I've got my negative 0.1, right? So they get us really close to that. And in this case, it looks like the limit just happens to be 0 because they're getting really, really close. So the limit's either going to be 0 or it's going to be some decimal somewhere in between there. It's a little difficult to tell, but that's why we are approximating. Yeah, let's go ahead and try this next one, which is just a conceptual one to make sure that we understand what a limit is. So it says if the limit of f of x as x approaches 3 is 4, which of these graphs could be that of f of x? So what this is telling me is that we have a function, f of x, could be any of these, and as x gets closer and closer to 3 from both sides, we want our y value to get closer and closer to 4. So let's take a look at here. We've got 1, 2, 3, okay, and we've got 1, 2, 3. Well, as x gets closer and closer to 3 from both sides here, y does not get closer and closer to 4, it gets closer and closer to 3. So in this case, this would be the limit as x approaches 3 of whatever function, we'll say g of x here, that limit equals 3 because it's getting closer to this point here. So this one is not one of the ones we want. It could not be that of f of x. Let's try this one. We've got 1, 2, 3. So as x gets closer and closer to 3 from both sides, it gets up to 1, 2, 3, 4. And yeah, it gets closer and closer to y equals 4 on here. So graph B could be that of f of x based on this limit. Let's check out graph C. Same thing. We've got 1, 2, 3. Okay. And then 1, 2, 3, 4, and it does approach a y value of 4 as it gets closer to 3 from both sides. So graph C could also be that of f of x. What about graph D? We've got 1, 2, 3, 1, 2, 3, 4. Good. So this one could also be that of f of x, and it's really important to note, I think I mentioned it earlier, this one has a hole. So the value of this function at x equals 3 is not 4. It has no value here that is undefined. So if we were to use direct substitution to find this limit, we can't. We have to use a different method because there's no value at this point. But that doesn't stop there from being a limit, right? Because it still approaches a y value of 4 as x approaches 3. So this limit is valid, and this could be f of x. For this next one, they give us that f of x is equal to x squared plus 4. So now we want to find the slope at these 2 points within this function. So the way that we find slope using limits is we set it up as the limit of, as x approaches a, of, let's see, it's f of x minus f of a over x minus a. This is going to be our slope at point A. So we're just going to plug in these values then. So let's see. That'll be the limit as x approaches 2 of f of x minus f of 2 over x minus 2 which we can rewrite. We're going to plug in the whole function here. Going to rewrite that. So we've got x squared plus 4 minus, and now we're going to plug in a 2 for that. So it's going to be 2 squared plus 4, which will be 8, all over x minus 2. All right, let's keep evaluating here. So we've got the limit as x approaches 2 of x squared minus 4 over x minus 2. And luckily for us, we can cancel out here because obviously we can't directly substitute because we'll have a denominator of 0. But we can factor out that x squared minus 4 is a perfect square. So it's going to be x minus 2, x plus 2 over x minus 2. And these can cancel out. So now we are just looking at the limit as x approaches 2 of x plus 2. And we can just plug that in. It'll be 4. So we have a slope of 4 here. All right, I'm erasing this. If you need to see it again, just go back. Oh my goodness, I didn't actually mean to erase that part. And now it won't let me undo it. But if you need to go back and look at anything or you're confused about it, Google's a good resource, so is Khan Academy, as well as many others, and you can obviously just go back and pause the video at any point. Remember again, the slope at point A is equal to the limit as x approaches a of f of x minus f of a over x minus a. So now we're going to find the slope when x equals 0.5 for f of x here. So we're going to set that up as x approaches a 0.5. We get f of x minus f of 0.5 over x minus 0.5. And again, same steps that we just took, right? Let's see, we're going to plug in that function. We get x squared plus 4 minus, let's see, 0.5 squared is going to be 0.25 plus 4, which will be 4.25 over x minus half. Okay, I'll just keep solving that out. So it's going to be an x squared minus a 0.25 over an x minus 0.5. And once again, we can factor this out because this is another perfect square. So you get an x minus 0.5, x plus 0.5 over x minus 0.5. And these cancel. Oops, I forgot my limit bit there. Whoops. Okay, and that turns into the limit as x approaches 1/2 of x plus 1/2. We plug that in, our limit is 1. I'm going to erase this just because it gets into our space a bit. It won't erase. There it goes. I think I've got maybe a little too much written on the whiteboard and it's lagging out. I don't know. Let's go ahead and try number 7 here. So again, we're just going to start off with direct substitution. So we're going to plug in that 2 where x goes, and that's going to get us an 8 minus a 2/7, which just happens to be 7 and 5/7 is our limit. Nice, easy one. This next one is just a little bit trickier because it is a piecewise function. So we first want to find the limit as x approaches 6 of f of x. So we're going to be finding the limit as x approaches 6 of f of x. And it tells us what f of x is as a function here. And since we're approaching 6, that's not equal to 3, which means we can do the limit of this bit here, which means we can just use direct substitution to find this limit. So that's going to be, let's see, -6/2 plus 3/8. It's obviously a -3 plus 3/8, which is a -2 and 5/8, I believe. And that's going to be our limit there. And then this time we want to find the limit as x approaches 3. But when x equals 3, the function equals 0. So at that point, we don't have any actual function to use. So if we were to go ahead and try and find that limit, it's not going to actually give us anything if we use this. So what we need to do instead is we need to go with the base function that's going to be around this point, right? Because every other point is going to be around x equals 3. And so as we get closer and closer to 3, those points are going to be following this function instead. So instead, we're going to do x approaches 3, and we're going to plug in that same function as before rather than the 0 there. So if I plug that in, that gets me a negative 3/2 plus 3/8, which is, let's see, negative 3/2, that's negative 6/4, negative 12/8 plus 3/8 equals negative 9/8 is our limit. All right, now we're given that f of x is equal to 3x squared, 3x squared minus 1. And using that, we want to find the equation of the line tangent to this function at the point 2, 11. So the first thing we need to do to find the equation of the tangent line is to first find the slope at this point. So remember that the slope at point A is equal to the limit as x approaches A of f of x minus f of A over x minus A. So we're going to go ahead and plug this function in for that. In this case, A is going to be 2, right? Because we're looking at our x values there. So we're looking for the limit as x approaches 2 of, I'm just going to skip a little step there, 3x squared minus 1 minus, we're going to plug in a 2 here, so it's going to be 3 times 2 squared, or 3 times 4, which is 12, so 11 over x minus 2, which turns into the limit as x approaches 2 of 3x squared minus 12 over x minus 2. This one is a little trickier, but I think I see a way. So we've got the limit as x approaches 2, and I can factor out here. I can factor out a 3 on that top. So I'm getting x squared minus 4 over x minus 2, and then seeing that, I see that this is a perfect square. So I can factor again, even further. And so we get a 3, and that's going to be an x plus 2 times an x minus 2. We're getting off to the side a little bit here, sorry. And these x minus 2's cancel. So now we're just looking for the limit as x approaches 2 of 3 times x plus 2. Plug in that 2, it's going to be 3 times 4, which is 12. So we've got our slope. So our slope is 12, but we don't have the equation yet, so we're not completely done. But the really, really good thing about that is that since we're finding the slope tangent to the line at a particular point, we already know an x and y value for our line, because it's just going to be that point. So I could either go, I could either use point slope form or slope intercept form for this. Slope intercept form is obviously y equals mx plus b, and slope intercept form is y, is this, which I expect that we're all a little familiar with, but obviously not everyone knows it super well. So in this case, I'm going to go ahead and do point slope form. So that's going to be a y minus 11 equals my slope, so 12 times x minus 2. So this is an equation of the line tangent to the point. I can also write that equation in my slope intercept form, so it's going to be y, we want to plug in our points so that we can figure out what b is, but we're going to start off y equals our slope, so 12x plus b. We need to figure out what b is, so plug in our points. Oops. Good, so 11 equals 24 plus b, which means b has to equal negative 13. So another way we can write this equation is y equals 12x minus 13. These both work. And yeah, that is our answer there. All right, we've just got 2 questions left. Let's take a look at this first one. It says if the position of a rolling ball is represented by the function s of t equals 2x squared minus 3, find the velocity when t equals 4. Okay, well, if anyone here is familiar with physics at all, will know that velocity is the derivative of position. And so what that means is that the slope of our position function is going to be our velocity at that point, which means that all we need to find is the slope of this function when t equals 4. And we know how to do that because slope at our point A, once again, equals our limit as x approaches A of f of x minus f of A over x minus A. So in this case, our A, or what we're approaching, is a 4. So we're going to find the limit as x approaches 4 of f of x minus f of 4 over x minus 4. I'm going to go ahead and just plug in the actual equation there, though. So then if I plug in my 4 to that equation, it's going to get me a 2 times 4 squared minus 3, which is 32 minus 3, or a 29, and that's x minus 4. Okay, let's keep going. Limit as x approaches 4 of 2x squared minus 32 equals 4. And I'm going to go ahead and factor out a 2 here. So I'm going to get 2 and then x squared minus 16 over x minus 4. Oops. And once again, I see this is a perfect square. So I'm going to factor that even further. That's going to be a 2 times an x plus 4 times an x minus 4, because it's that perfect square. Then x minus 4 and my x minus 4's cancel. So now we are just looking at the limit as x approaches 4 of 2 times x plus 4. Now I can plug that in with our direct substitution, and we get 2 times 4 plus 4, or 2 times 8, which is 16. So the velocity at that point is going to be 16 whatever units. Let's say meters per second squared or what have you. Yeah, because that is our slope. So that is our answer there. And then for our very last one, this is another conceptual one. So for number 11, it asks, does this function have a limit at x equals 3? We're going to look at x equals 3 right here, and we kind of see that there's actually an asymptote. An asymptote doesn't mean that there's not a limit, because necessarily, it just means that the limit might be infinity or negative infinity, which we technically consider not existing, but if we know that it goes to infinity or negative infinity, we typically want to write that. In this case, though, we see that from one side it goes to negative infinity, and from the other side it goes to positive infinity, which means that the limit from the left and the limit from the right are not equal, so the limit does not exist. So this function does not have a limit at x equals 3. The answer is no. If you have any further questions, I think as I mentioned earlier, again, Google, Khan Academy, and many others are wonderful resources. And yeah, I hope that this helps.